Yeah. Oh, yeah. Welcome back. Uh, okay. Now, having looked at what chemical equilibrium is all about, we have been able to establish the fact that a chemical equilibrium only exists when you have the rate at which forward reaction is proceeding being equal to the rate at which backward reaction is also proceeding. And that is exactly what is making a system, or that's exactly what could make a system to be undergoing a chemical equilibrium, to be undergoing equilibrium. Okay, but this now we will not be looking at factors affecting chemical equilibrium. We look at factors affecting chemical equilibrium. Okay, now uh, those factors are this: they are concentration, okay, temperature, and the last one is pressure. Usually, catalyst is not really there, so but most times they want to use this catalyst to want to confuse you in the exam. Catalyst does not have any effect in equilibrium system. It does not have any. It does not affect the system. It only helps the system to proceed, at a faster rate. Okay, that is the essence of the catalyst. So, uh, concentration, temperature, and pressure always affect chemical equilibrium. So what do we mean by that? It's just like you have a system that is already balanced. So the same way, the equilibrium system is also disturbed. You're assuming that a system that is already proceeding forward at the same time already proceeding backward at the same rate, that's what's making it to be stable. That's what's making it to be in the state of equilibrium rather. So if it is state of equilibrium, you now come and increase the concentration of any of the chemical that is in the system. What I'm saying is that let's say you have A and B being together to form C and D. Okay, okay. I told you earlier that primarily this, or let me say mostly, this usually make a system to be in equilibrium. But not every time, but most times you have this arrow, a reversible reaction. Though not every time. But we normally use this, just to explain. Okay. Now let's say the reaction is proceeding in both ways at the same time. So that means the system is already in equilibrium. The system is already balanced. Okay. You now come and you now increase the concentration of A, or you increase the concentration of B, or you decrease the concentration of A, or you decrease the concentration of B. What do we mean by that? What we mean by that is that you now put more of A, you add A. Let's say this is, for example, water, and this is, for example, salt. So I want to use a very good example, a very physical example, what you do every day. Okay, okay, what you do every day, what is feasible before we now come into the lab, the chemistry lab, where we'll now be using the the compound or elements that are best fit to use as an example, to explain chemical equilibrium. I mean, to explain the factors affecting equilibrium. Okay, so let's use this. It's just like you have water and salt, and this water and salt, for example, is already balanced. It's already in the state of equilibrium. I am not saying water and salt will always tend to produce an equilibrium system. Okay, what I'm saying is that let's assume that this A is water and this B is salt. I want to explain something. Okay, now let's say this system is already balanced. Let's say it's already giving us something. To use other examples to back it up later. So when you have A and B, you now come. This is A, which is water, B, salt. You now pour more of water inside. What you are doing is you are increasing the concentration of A. Or you pour more of salt inside. That means you are increasing the concentration of salt. Or you are removing water. That means you are decreasing the concentration of A. Or you find a way of removing salt. That means you are decreasing the concentration of B. What you are doing here you are disturbing the system. The system will no more be in equilibrium. So you are affecting the system. You are disturbing the system. Okay, that is concentration. That's how concentration affects. Concentration does affect equilibrium. A system that's already in equilibrium, you come and increase the concentration or you decrease the concentration either of the reactant or of the product. You are already disturbing the equilibrium. So at the same time, temperature too can also affect the equilibrium. Temperature, okay, maybe this thing is in endothermic state. What we mean by endothermic state is that is 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 absorbing heat from surrounding. That's the meaning of endothermic. Anytime we are explaining temperature, temperature could either be in exothermic form or it could also be in endothermic form. If it is endothermic form, we mean it is absorbing heat from the surrounding. If it is exothermic, we mean it's evolving heat to the surrounding, meaning that the heat is too much that it has to give it out to the surrounding. Why this endothermic? What it means is that the heat is just average or is not enough, so it needs heat again. Okay, so it has to absorb heat from the surrounding. That is what's making it to be endothermic. So this thing now, this system now is already maybe is endothermic. Okay, mostly I will know an system to be in endothermic state or exothermic state is, I mean, it depends on the energy content. Now, if content is positive, okay, we say it is endothermic. But if the energy content is now negative, we say it is in what? Endothermic state. We say it is in what? Endothermic state. So now let's say this system now, which is already balanced, which is already in equilibrium, and at that point the energy content is positive. And energy content is positive, is endothermic. Okay, now if you have that, okay, if you have that, the system is balanced with the regard of the normal concentration that is there, with the regard of the heat content which is positive. Now, at that point is in the state of chemical. You now come and increase the temperature of this, or you decrease the temperature of this, you are affecting the system, you are disturbing the system. Okay, so anything that will make you to change something in the system, okay, so it's an attempt to disturb the system. Okay, so even pressure too affect the system. You increase the pressure of but when you're increasing pressure, most times we don't take it individually. Most pressure in, I mean, you can increase the pressure at the reactant, or you increase the pressure at the, you can increase pressure, you can decrease the pressure at the product, or you decrease the pressure at the reactant. So irrespective of the one you are doing, you are still disturbing the system. Okay, so okay, factors that affect equilibrium. Equilibrium is so wise. Layers principle. So this principle is a principle that explains what is actually happening when a system is disturbed. So this principle explains what is actually happening. How does system react? How does that equilibrium system respond to the disturbance? How does it respond to it? How does it take care of it? Because you see, this equilibrium of a thing is very useful, in the industrial production of some chemicals, in industrial production of some gases. So it's very useful. Okay, so okay, so that I will not debate much. This principle, you have it in your note already. But what this principle is saying is that uh, whenever you have a system already in the state of equilibrium, when the system is now disturbed, an equilibrium system is now disturbed, okay, system usually, okay, adjust itself, okay, so that it will neutralize or it will annul, okay, so that it will neutralize or annul the effect of the change. Okay, this annul and this neutralize, okay, uh, means that it want to take care of that change that has happened, because those factors that you are applying, those pressure, those, I mean, the concentration, the temperature that you are applying, is an attempt to disturb the system. It's an attempt to change the system. What system does is to adjust itself so that to neutralize or to annul the effect that must have been caused by those factors. Okay, so that is what the general principle is all about. It want to take care, it want to annul, it want to neutralize whatever the disturbance those factors must have caused. So this principle, okay, made us to understand that system usually adjusts itself, okay, adjust itself so that it will annul or it will neutralize the effect those applied factors must have caused. Okay, so um, how does the system does that? How does it do that?